Off we go. We're on live now. All right. Now, first thing we've got to do is question one. This is from the 2021. What paper is it? I've forgotten. It is the 2022 paper. Oh no, it's the March 2020 paper. Okay. Right. Someone else is trying to get in. Let's see who that is. Annabelle. All right. There we go. I think we're all good now. All right. I think we're all pretty good. Right. Here we go. The table shows numbers of protons, neutrons, electrons. I'm going to try and do a whole paper in like 20, 30 minutes and see if I can do it. Answer the following questions about A to I. Each letter may be used once, more than once, not at all. Which one is an anion? Now, this is how we do this quickly. An anion is a negatively charged thing. A cation is a positively charged thing. If you're an anion, it means you have more electrons than protons, and obviously if you're a positive thing, you have more protons than electrons. So let's have a look. Protons 1, this has more protons than electrons, so this one is a cation. So let me put a 1 here. Oh, which one is that? A is that. B, they have the same, so that's neither. C, they've got the same. D, they've got the same. E, there are more electrons than protons, so that's negatively charged. So E is an anion. F, they're the same, they're the same, they're the same. I, there are more protons than electrons, so I is a cation. Which ones are noble gases? Noble gases are 10 and 18, okay? How do we know that? 2 is a noble gas. 2,8 is a noble gas. 2,8,8 is a noble gas. This makes up 2 electrons, or 2 protons. This is 10 and this is 18. So the noble gases are D and G. D and G. Which one is a halogen? A halogen is going to be in group 7, and that's going to be one less than a noble gas, so that's going to be F. F is a halogen. Which one is a group 1? Group 1 is going to be one more than a noble gas. There's a noble gas. One more than a noble gas is H. I think I've got this wrong way around. Yeah, that's right. H is a group 1. Have the same nucleon number. Nucleon number is protons and neutrons added together. So this has 1. This has 12. This has 14. This has 20. This has 32. This has 35. This one has 40. This one has 40 as well, isn't it? So it's G and I. They've got the same nucleon numbers, which causes acidity in aqueous solutions. All right, that's going to be an element, isn't it? That's on the right-hand side of the table. So chlorine, when you dissolve chlorine, you get an acid. You get HCl, and you get something called hypochlorous acid. So already we know what fluorine is, which proton number 17 is used to define the relative atomic mass of elements. And that one's carbon, isn't it? Carbon has carbon 12, 6. So we're looking for 6 protons, 6 neutrons. There you go, B. Okay, that's carbon 12. All right, now we're done with that. Explain why B and C are isotopes. B is and C, well, they're isotopes because they have the same proton number. Okay, but they've got different neutron numbers. All right. Another way we could say that, they have the same atomic number, but they have different atomic masses. Different atomic masses. There you go. That's a nice way of doing it. So there you go. Any questions there? 12 marks now. That's quite a long way into the paper, actually. 12 marks. Everybody okay? I guess we're okay. If you want to say something, please put it in the comments, and then I'll look at them. Otherwise, I'll just move on to the next one. All right, that was quite a simple one. Next one looks like a halogen question, or a periodicity question. Let me get rid of this rubbish. Oh, gosh. There you go. Can we select all? I don't think so. All right, let's try and select as much as I can. There. Okay, and paste this. There we go. Okay, this one looks like a periodicity question. All right, here we go. All right. Hydrogen, nitrogen, oxygen, and chlorine. Which one is green? Obviously, chlorine is green, so chlorine is green. Gases are diatomic. State the name of another element which has diatomic molecules and is a gas at room temperature and pressure. Apart from these, I guess it means. All right, well, fluorine is Oh, what's that? Fluorine is diatomic, so they want the name, don't they? State the name. So fluorine, that's U. Fluorine is diatomic. What else is diatomic? Oh, I'm sure there's millions, but I just can't think of them. Fluorine is diatomic. That's the only one I can think of at the moment. All right. When separate samples of each gas are placed in a container, they diffuse. Why do gases diffuse? Is because the particles are in constant motion. Okay, they're always moving around. That's why they diffuse. Which one diffuses at the highest rate? Now, as you all know, relative atomic mass, is inversely proportional to the rate of diffusion. All right. So the higher the mass, the slower it diffuses. So hydrogen has a mass, its H2 molecules has a mass of 2, so it's going to diffuse the fastest. So the gas diffuses the fastest is hydrogen, and it has the lowest molecular mass. And there you go. Someone's knocking on the door. Let's have a look at this. Oops, wrong one. Let's have a look at this again. All right, Demohol wants to come in. Hello, Demohol. Right, there you go. So there we are. State the percentage of nitrogen in clean air. It's about 78%, isn't it? Something like that. Other than nitrogen and oxygen, identify another element in clean air. Argon is about 1% of air. Identify compounds found in dry, clean air. Compounds. Carbon dioxide is a compound in air. All right. Nitrogen and oxygen can be separated from air. Set the process. It is fractional distillation. That's how we separate the elements of in air, okay, in liquid air. Another 10 marks. So, yeah, that's pretty good. So far, we've done 22 marks, and we're doing pretty good. Okay, let me look at the next one. Next one looks like an equilibrium question. On purpose, I'm going fast, it's best I show you how easy these things are, I think. It's a good way of doing it. So I want to finish the whole paper, right? Whoopsie daisy. I want to finish the whole paper as quick as I can, and then it makes you realize how easy these things are. All right, we've got nitrogen reacts with hydrogen to form ammonia. Name the industrial process. This is called the Haber process. Interesting video if you want to watch about Fritz Haber on Vericitium. All right, the YouTube channel. It's a really interesting one about him. State the meaning of this term. This means a reversible reaction. State the conditions used in the process. Air 400 we use, pressure 200 atmospheres. Actually, I think this is often 450 these days, isn't it? Name the catalyst. It's iron. It's often what we call finely divided. Now, finely divided is just a fancy way of saying it has a large surface area. Okay, there we go. If the pressure is increased, what happens to the yield increases? Why? Well, on the left-hand side, we have 4 gaseous molecules, and on the right-hand side, we've got 2 gaseous molecules. If you increase the pressure, since there are, how many have we got? 4 gaseous molecules, or moles, if you like, on the left-hand side, which is greater than the 2 gaseous molecules on the right-hand side. So an increase in pressure, it goes to where there are more gaseous molecules to where there are less. Okay, that's why the yield increases. Equilibrium shifts to the right. If the temperature is increased, the rate of reaction increases. Explain in terms of particles. Now, obviously, you've got to say a couple of these things. Increasing the temperature will increase the kinetic energy of the particles. Okay, this will lead to an increase in molecular collisions. Collision frequency, we should say. In other words, they hit each other more often. Also, if you increase the temperature, more molecules have kinetic energy greater than the activation energy. Okay, so you are likely to get more successful collisions because if they've got enough energy, they'll bash each other, but they won't just bash each other; they'll bash each other and they'll react. Ammonia reacts with sulfuric acid to make a compound which is used as fertilizer. Write a chemical equation for the ammonia with sulfuric acid. Well, ammonia is NH3. I guess we're going to say gas, even though it could be dissolved in a something like that. H2SO4. It's actually a liquid. All right, you react these two together, you get something called ammonium sulfate. We need 2 of those. Okay, I think that's it, isn't it? Yeah, that's it. We've done it. And this will actually be formed as a solid ammonium sulfate. It will be a solid. Even the state symbols are a bit confusing here, so maybe we shouldn't have them this one because this is done quite a weird way. All right, we've done 32. We're nearly halfway through the paper already. All right, let's have a look at the next one. Next one looks like a salt preparation one. Okay, let's get rid of that. Let's get rid of that. And let's put this there. Alrighty, so this one. The student wants to make some zinc chloride. Where are we? There we are. Student wants to make some zinc chloride. It does these things. Step 1, add zinc to dilute HCl. Remove the unreacted zinc. Heat the solution. Saturate it. Allow the saturated solution to cool. Remove the crystals that form. Write an equation for the reaction in step 1, including state symbols. Now that's obvious. This is a metal. We can use a different color. I'm bored with that color. All right, so we have zinc, which is a solid, plus HCl, which is aqueous. We're going to get zinc chloride, which is aqueous, and we're going to get hydrogen involved, which is gas. Since we've got ZnCl2, we need 2 of these. That's 3 marks for that. My God, seriously? I guess you've got to include state symbol, so I guess it is worth 3, but that's a lot of marks. Explain why excess. We use excess zinc with what? We use excess zinc to ensure all the acid reacts. Okay, it's all used up. All the acid gets used up. We don't want any acid in the end. Suggest how we get rid of the zinc powder. You would filter it because it doesn't react, does it? Saturated solution. What do we mean? What do we mean by saturated solution? It is one where I should say, no more solutes can dissolve in the solvents. Okay, it's saturated. It can't hold anymore. It's a solution that can hold no more solute. All right. Explain what the crystals form as the solution cools in part 2. Well, because the what shall I say? The solubility of the crystals decreases with decreasing temperature. In other words, if I cool it down, they must come out of solution because their solubility decreases. All right. The only way they can do that is they've got to come out. We say the crystals come out of solution. Name 2 zinc compounds which react with dilute HCl to form zinc chloride. You should all know this. Acid. It reacts with metals. It reacts with carbonates. And it reacts with bases. You should know these equations off the top of your head. You always get salts with these. All right. Now, we've already done the metal, but what about a carbonate? Well, name 2 compounds. Zinc metal will react, but we've already done that one. Zinc carbonate. Now, that's the carbonate sorted out. Now we need a base. Well, zinc oxide is a zinc compound. We could also use another base, zinc hydroxide. Okay. If excess calcium metal is used instead of excess zinc, is step 1, the pure calcium chloride do not form. Explain why. This is quite a hard question, actually. All right. If we drop in calcium, okay, calcium there, where are we? In step 1. Step 1 is using HCl. If we drop calcium in, you'll get the calcium will react with water. It reacts with water, and you get calcium hydroxide. Okay, because calcium is so reactive, it reacts with the water. So the calcium will react with the water, with the water and form calcium hydroxide. Yeah, something like that. That will do. Okay, next one. Oh, this is calculation. Oh, we can relax a little bit. My word, 17 marks this question. All right, let's get rid of this rubbish. Let's get rid of, copy this and paste there. Okay. All right, now we've got some salts can be made by titration. In a titration experiment, 20 cc's of aqueous sodium hydroxide reacts with exactly 25 cc's of 0.1 mole of dilute sulfuric acid. There's the equation. Circle the name of the type of reaction that takes place. It is, well, look at this, we get water formed, and we call those neutralizations. All right, this is a neutralization reaction. Now, calculate the number of moles of sulfuric acid used. We've got our equations. Now, number of moles is equal to CV. I have no idea what's going on with my pen. I'll leave it. CV, all right, concentration times volume. Concentration of the sulfuric acid, where is it? There it is. So it's 0.1 times the volume of sulfuric acid, which is 25 cc's. Now we have to put that in decimeters cubed. So there you go. Now where's my calculator? Should have done this before. 0.1 times 25 exponential minus 3, 2.5. Okay. This is 2.5 times 10 to the minus 3. 2.5 times 10 to the minus 3 moles of sulfuric acid. Determine the number of moles of sodium hydroxide to react. Well, if we can sneak in this, 2.5 times 10 to the minus 3, this is going to be 2.5 times 10 to the minus 3 times 2, because the coefficient is 2 to 1. Okay, so that number times 2, whoops, daisy, which is obviously going to be 5 times 10 to the minus 3, isn't it? Okay, calculate the concentration of the aqueous solution in moles per decimeter cubed. All right, now concentration is equal to the number of moles divided by the volume of water in decimeters cubed. Someone's knocking on the door. Let's have a look who it is. It is Zara. Well done. Hello, Zara. Anyway, so the number of moles is 5 times 10 to the minus 3. There is that number. Divided by the volume. The volume of sodium hydroxide is 20. So we divide that by 20 times 10 to the minus 3. It's got to be divided by 20 times 10 to the minus 3 because it's got to be in decimeters cubed, doesn't it? So 5 divided by 20 is equal to 0.25. So this is 0.25 moles per decimeter cube. Calculate the concentration in grams per centimeter cube. Now we have 0.25 moles, all right, dissolved in 1 decimeter cubed, and I want to find out how many grams are dissolved in that. Well, I simply times by the relative molecular mass. Now the relative molecular mass of sodium hydroxide is what's sodium? 23 plus 16 plus 1, which is 40. So 0.25 times 40 is 10 grams per decimeter cubed. And there you go. 17 marks there, piece of cake. Okay, that was quite a straightforward question. Now we're looking at the organic, I think. Number 5. Okay, whoops, daisy. Get rid of this rubbish, get rid of that rubbish. Paste this, make it big. Okay, table shows the names of structures of elements P to U. There they are. Give the letter of the organic compounds P to U that are unsaturated hydrocarbons. Well, that's saturated. This is not a hydrocarbon, is it? This is unsaturated means it has a double bond. So this is saturated. It is a hydrocarbon, but it's saturated. So this is not the answer. This is not a hydrocarbon. But-1-ene is a hydrocarbon, and it is a unsaturated one. So R is an unsaturated hydrocarbon. Propanol isn't a hydrocarbon. An ester isn't a hydrocarbon. This guy is a hydrocarbon. There's a double bond there, and that means it's unsaturated. So that's U. R and U. Describe a test for saturation. You mix with bromine water, as you all know. Okay, and it decolors, doesn't it? Decolors the bromine water. In other words, it makes it go colorless. All right. But-1-ene is unsaturated, namely unbranched isomer of butanene. Whoops, now unbranched. Now butanene, let's go over here. Looks like this: 1, 2, 3, 4, and there's a double bond between 1 and 2. Okay, we've got to draw a similar one, unbranched, in other words, straight chain, and I'm just going to change the position of the double bond. So the unbranched isomer is butene. Simple as that. Draw the structure of a branched isomer of butanene. Now it wants me to branch it, so 1, 2, 3. I've got to branch it now. Branching means there's a kink in the chain. Put a double bond there and fill in my hydrogens. There we are. 1, 2, 3, and there we are. This is actually called, if you're interested, let me get a nice different color here. This is called methyl propene. Okay, 2-methylpropene. Dodecane is an alkane with 12 carbon atoms. Dodecane can be cracked. Right, a formula of dodecane. Well, the general formula is CnH2n plus 2. If there's 12 carbon, so it's 12. 2 times 12 is 24, plus 2 is 26. There you go. Give the letters of all the organic compounds P to U that can be formed when dodecane is cracked. Well, you can get P. Whoops. You can get P. Any hydrocarbon, basically. You can get that. You can get that because it's another hydrocarbon. So you can get P. You can get R. You can get U. PRU. Any hydrocarbon. You get any old thing if you crack things, believe it or not. All right. It depends where they crack. So P, R, and U. All right. Next. Whoopsie daisy. Now rushing down to this one. God, these questions are actually quite heavy on the marking. Like 17 marks, 20 marks. This is March 2021. So far, there's been nothing nasty, though. All right, let's have a look at this one. Now obviously I've got rid of the table that I need. Name the reagent that suggests the conditions needed to convert organic compound U. Now, obviously, I've got to pick my compound U up. Let's put it over here. All right. Oops. Let's put it underneath. Okay. What do I have to do? I have to convert organic compound U into organic S. U to S. Now let's make this smaller. Let me see. U is that. S is propanol. So obviously I have to add water to that, don't I? Okay, that's how you convert a alkene into an alcohol. So the reagents are, we need H2O. All right. That's the only reagent we need, water. And we need the, what is it? Propene, don't we? We need the propene as well. What are the conditions? 200 degrees C, and we use a phosphoric acid catalyst. All right, they're the conditions. And the whatever. Organic compound S. Oh, bloody hell, why is it doing this? Organic compound S can be converted to Q. All right, S to Q. S is propanol, Q is propanoic acid. So what we've done then is we've reacted propanol with, reacted propanol, we've oxidized propanol, and it oxidizes to propanoic acid. So this is an oxidation. And then the type of chemical change, that is an oxidation. Name the acidified reagent. The one we use is potassium manganate. 6. Is it 6? No, it's 7, isn't it? Potassium manganate 7. All right, acidified. Organic compound T is made by reacting two compounds. Which one is T? T is that. So T is the ester. So you've got methyl butanoate. You react methanol and butanoic acid to make that ester. Name homologous series which T belongs. They belong to the esters. Name two compounds which react together to form compound T. Well, one of them is methanol. This is the alcohol part. Methanol looks like this. And what was it again? It was butanoate. So the other thing is butanoic acid. Butanoic acid. That's 4 in a row. 1, 2, 3, 4. There's my acid bit at the end. So when butanoic acid reacts with methanol, you get methyl butanoate. There you go. Deduce the molecular formula of compound T. Oh, really? Which one's T? Is it always that one again? So the molecular formula is C4, 1, 2, 3, 4, 5, 6, 7, 8, H8, O2. Okay, done with that one. All right, that's that question. 20 marks, quite a lot. All right, let's have a look at the next one. Next one looks a bit nastier. This is on polymerization. Okay, so let me grab this. Okay, whoopsie daisy. All right, now this is this one. All right, polymers are large molecules built from up small molecules. State the name given to the small molecules from which polymers are made. They are known as monomers. Okay, formula of this is this. To draw a structure of the small molecule. The way we do that is we ignore this bond, and draw a double bond there. So we get C double bond, H, H, CH3, CH3. All right. There you go. I think I've drawn everything there. Show all of the bonds. Oh dear, I haven't done it right, have I? So let me get another pen. Let me get a red pen. I should have done this. All right. Now I'm surprised Cambridge at this level normally don't do this. Now I'm drawing all of the bonds, which they do ask for. So there you go, and that's but2e. State the type of polymerization used. Well, it's about double bonds. It's about alkenes, so it is addition. Addition. All right. Next, 3. Oh gosh, what's that doing there? 3 amino acids are shown that and that with different boxes in the middle. Name the type of natural polymer form when amino acids combine. If amino acids combine, you get proteins. Okay, complete the diagram to show the parts when 3 amino acids come together. Right, I'm going to do the NH2 over there, which is that bit. And I'm going to get the C double bond O bit over there, which is that bit. And now I'm going to form these linkages in the middle. These are known as amide linkages. If you do biology, they're known as peptides. Okay, and this thing, because you get from 3 amino acids, this is known as a tripeptide. That's just interesting. Name the type of chemical reaction that takes place when this natural polymer is converted back to amino acids. Now, when we go back from this to this, we call that a hydrolysis. And that, ladies and gentlemen, is the whole paper done. All right. So I hope you realize how easy these things are. Let me turn off the video.